Most people who fail SAA-C03 struggle with one thing: AWS storage scenarios. Stay with me, and we'll solve the most common storage questions step by step so you don't lose easy marks in the exam. One member of your DevOps team consulted you about the best storage which can handle the following requirements: can be scaled automatically, can be accessed concurrently by multiple EC2 instances, support file level locking. What is your recommendation? The options are A, Amazon EFS, B, Amazon Snowball, C, Amazon S3, D, Amazon EBS. This question tests whether you can identify the AWS storage service that meets all three requirements simultaneously. The critical keywords are scaled automatically, accessed concurrently, and file level locking. Only one AWS service checks all these boxes. The correct answer is A, Amazon EFS. Why option A is correct? Amazon EFS, Elastic File System, is the only service that perfectly satisfies all three requirements simultaneously. First, EFS scales automatically. It's elastic, automatically growing and shrinking as you add and remove files without any manual intervention or downtime. You never need to provision capacity. It adjusts in real time as your storage needs change. Second, EFS supports concurrent access from multiple EC2 instances. You can mount the same EFS file system to thousands of EC2 instances simultaneously across multiple availability zones, regions, VPCs, and even on-premises servers. Third, and most critically, EFS provides file-level locking because it's a fully POSIX-compliant file system with file system access semantics, including strong consistency and file locking capabilities. This means multiple instances can safely read and write to the same files without conflicts, using standard file locking mechanisms that applications expect. Why the others are wrong? Option B, Snowball, is incorrect because Snowball is a physical data transfer appliance for migrating large amounts of data to from AWS. It's not a storage service that EC2 instances can access concurrently. Option C, S3, is incorrect because S3 is object storage with a REST API interface, not a file system. It doesn't support file-level locking or mounting to EC2 instances like a traditional file system. S3 uses eventual consistency for some operations and has no concept of file locking. Option D, EBS, is incorrect because EBS volumes can only be attached to a single EC2 instance at a time in a single availability zone, except for multi-attach, which is limited to 16 Nitro instances in the same AZ with specific volume types. Additionally, EBS requires manual scaling. You must manually increase or decrease volume size and attach detach volumes. Quick takeaway, memory tip, EFS equals elastic file system equals shared file system. When you see concurrent access plus automatic scaling, file level locking together, always choose EFS. Remember the storage hierarchy. EBS equals one instance, block storage. EFS, multiple instances, shared file system with locking. S3, object storage, no file system. EFS is the only AWS service that acts like a traditional NAS, network attached storage, device in the cloud with POSIX compliance. If this video is helping you, support us by hitting the like button, and don't forget to subscribe for more content like this. Which AWS service allow users to upload, store, and share millions of documents in a secure, low-cost, and high-performance way? The options are A, Amazon EFS, B, AWS Lambda Function, C, Amazon CloudFront, D, Amazon S3. This question tests your knowledge of AWS storage services, specifically designed for massive scale document storage with requirements for security, cost effectiveness, and high performance. The key phrases are millions of documents, secure, low cost, and high performance. The correct answer is D. Amazon S3, why option D is correct. Amazon S3, Simple Storage Service, is specifically architected for exactly this use case, storing millions or billions of documents. First, it's highly scalable. S3 provides unlimited storage capacity with no theoretical limits on the number of objects you can store, making it perfect for millions of documents. Second, it's secure. S3 offers multiple encryption options: SSE S3, SSEC, SSE-KMS for data at rest and in transit, plus fine-grained access controls through bucket policies and IAM, meeting compliance standards like PCI DSS, HIPAA, and FedRAMP. Third, it's low cost. S3 uses a pay-as-you-go pricing model starting at just a few cents per GB per month, with lifecycle policies to automatically move infrequently accessed documents to cheaper storage tiers like S3 Glacier. Fourth, it's high performance. S3 delivers 99.9999999% durability, 11 nines, and 99.99% availability, with automatic replication across multiple availability zones and low latency access. You can store any file type from 0 bytes to 5 terabytes per object, share documents via pre-signed URLs or public links, and access them through REST APIs, SDKs, or the web console. Why the others are wrong? Option A, Amazon EFS, is incorrect because EFS is a shared file system designed for concurrent access by multiple EC2 instances using file system protocols. It's more expensive than S3 and not optimized for storing and sharing millions of independent documents. Option B, AWS Lambda, is incorrect because Lambda is a serverless compute service for running code, not a storage service. You can't store documents in Lambda functions. Option C, Amazon CloudFront, is incorrect because CloudFront is a content delivery network, CDN, that caches and distributes content globally. It's a delivery mechanism, not a storage service. While CloudFront often works with S3 to deliver documents faster, it doesn't store them. Quick takeaway. Memory tip. S3 equals simple storage for scalable documents. When you see store millions of files documents plus low cost plus secure high performance, always choose S3. Remember, S3 equals object storage for unlimited files. EFS equals file system for EC2 sharing. Lambda equals compute, not storage. CloudFront equals CDN for delivery, not storage. S3 is the gold standard for document storage with 99.99999% durability, perfect for everything from backups to media libraries to document management systems. A research company wants to securely share its scientific data stored in Amazon S3 bucket to other companies' AWS accounts. As a solution architect, which S3 feature can achieve this requirement? The options are A, lifecycle policy, B, AWS data sync, C, bucket policy, D, bucket replication. Think of a bucket policy like a building's guest access list that specifies exactly which outside companies' AWS accounts can enter specific rooms, S3 buckets, and what they're allowed to do once inside, read files, upload files, etc. It's a permission document attached directly to the bucket that says account B with ID 123456789 can access my data. The correct answer is C, bucket policy. Why option C is correct? S3 bucket policies are the primary and most straightforward method for granting cross-account access to S3 buckets. A bucket policy is a JSON-based access policy document that you attach directly to an S3 bucket to define who can access the bucket and what actions they can perform. For cross-account access, you specify the external AWS account's ARN, Amazon resource name, in the principal field of the policy. Then grant specific permissions like S3 get object, read, S3 put object, write, or S3 list bucket, list contents. For example, the research company would create a bucket policy that explicitly allows the other company's AWS account ID to access specific objects or the entire bucket. This approach is secure because you maintain full control over exactly which accounts have access and what they can do. And you can revoke access anytime by updating or removing the policy. The bucket owner retains complete ownership and control while selectively sharing access. Why the others are wrong? Option A, lifecycle policy, is incorrect because lifecycle policies are used for automating object management tasks like transitioning objects to different storage classes, e.g., moving to Glacier after 30 days or deleting objects after expiration. They have nothing to do with access control or sharing. Option B, AWS data sync, is incorrect because data sync is a data transfer and migration service used to move large amounts of data between on-premises storage and AWS, or between AWS storage services. It's not an access control mechanism. Option D, bucket replication, is incorrect because replication copies objects from one bucket to another bucket, same or different regions. It duplicates data rather than sharing access to the original bucket. The other company would need their own bucket, and you'd be creating copies, not granting controlled access to your data. Quick takeaway, memory tip, bucket policy equals cross-account access pass. When you see share S3 data with other AWS accounts or cross-account access, always choose bucket policy. Remember, bucket policy equals you can access what in your bucket. Lifecycle policy, when to move, delete objects. Data sync, how to transfer data. Replication, copy data to another bucket. Bucket policies are the standard AWS solution for controlled cross-account S3 access with the principal field specifying external account ARNs. You work in digital media company. The company has more than 200 TB of videos are infrequently accessed, but when accessed, it is acceptable to be retrieved within 1 hour. Which low-cost AWS service can handle this requirement? The options are A. Amazon S3 Standard, infrequent access. B. Amazon Glacier, expedited retrievals. C. Amazon Glacier Standard retrievals. D. Amazon Glacier bulk retrievals. This question tests your ability to distinguish between infrequently accessed operational data versus rarely accessed archival data. The key phrases are infrequently accessed, not archival, acceptable within 1 hour, rapid access is fine, and low cost. The correct answer is A. Amazon S3 Standard Infrequent Access. Why option A is correct? Amazon S3 Standard IA, infrequent access, is specifically designed for this exact scenario. Data that is accessed less frequently, but requires rapid, immediate access when needed. S3 Standard IA provides millisecond-level retrieval times, meaning videos are available instantly without any retrieval delays or restoration requests. This far exceeds the within 1 hour requirement while remaining cost-effective. For 200 plus TB, S3 Standard IA offers storage costs about 45% lower than S3 Standard, around 0.125 per GB versus 0.23 per GB, making it economical for large datasets. The key distinction is that infrequently accessed media files in a digital media company are still operational data that teams need quick access to for editing, distribution, or client requests, not archival data buried in cold storage. S3 Standard IA maintains 99.9% availability and 99.9999999% durability with no retrieval wait times, perfect for business-critical content that's accessed occasionally. Why the others are wrong? Option B, Glacier Expedited, is incorrect because while expedited retrievals take 1 to 5 minutes, meeting the 1 hour requirement technically, Glacier is designed for archival storage of rarely accessed data, not operational media files in a digital company. You'd also pay higher retrieval costs and must initiate restoration requests, adding operational complexity. Option C, Glacier Standard, because standard retrievals take 3 to 5 hours, which exceeds the 1 hour acceptable retrieval time stated in the requirement. Option D, Glacier Bulk, is incorrect because bulk retrievals take 5 to 12 hours, far exceeding the 1 hour requirement and designed for large-scale archival retrievals where time is not a factor. Quick takeaway. Memory tip. IA equals instant access for infrequent use. S3 Standard IA is for infrequent operational access, milliseconds, while Glacier is for rare archival access, hours. When you see infrequently accessed plus rapid access when needed is acceptable within 1 hour, choose S3 Standard IA, not Glacier. Remember, infrequent to archive. Digital media companies need operational flexibility, not cold storage delays. S3 IA equals instant availability at 45% cost savings versus S3 Standard. You are designing a retail website, which will use EBS volumes as primary storage. These EBS volumes are attached to multiple EC2 instances at the same time. What is the best solution to back up these EBS volumes in another region? The options are A. Use Lambda function copy data from the current Amazon EBS volumes to the Amazon EBS volume in the other region. B. Create point-in-time snapshots of volumes, then copy it from the current AWS region to the other region. C. Store the data in Amazon S3, then enable cross-region replication. D. Enable cross-region replication in the current Amazon EBS volumes. This question tests your knowledge of EBS backup strategies and cross-region disaster recovery. The key requirements are backing up EBS volumes and storing those backups in a different AWS region for protection against regional failures. The correct answer is B. Create point-in-time snapshots of volumes, then copy it from the current AWS region to the other region. Why option B is correct? EBS snapshots are the native AWS recommended method for backing up EBS volumes. Snapshots capture the exact state of your EBS volume at a specific point in time as an incremental backup stored in Amazon S3, behind the scenes. Once you create a snapshot in your primary region, you can easily copy it to any other AWS region using the AWS Console, CLI, or AWS Backup Service. This cross-region snapshot copy provides robust disaster recovery protection. If your primary region experiences an outage, you can restore EBS volumes from snapshots in the secondary region and attach them to new EC2 instances. The process is efficient because after the first full snapshot, subsequent snapshots are incremental. Only changed blocks are saved, reducing storage costs and copy times. You can automate this entire process using AWS Backup, with backup plans that include copy rules to automatically replicate snapshots to destination regions on a schedule. Why the others are wrong. Option A, Lambda function, is incorrect because Lambda has a 15-minute maximum execution time and limited temporary storage, 10 gigabytes TMP. It's not designed for copying large EBS volumes, which can be up to 64 terabytes. Additionally, you can't directly copy data from one EBS volume to another across regions using Lambda. Option C, store in S3 with replication, is incorrect because EBS volumes can't be directly stored in S3. They're block storage devices, not objects. While EBS snapshots are stored in S3 behind the scenes, this is handled automatically by AWS, not through manual S3 operations or S3 cross-region replication. Option D, cross-region replication on EBS, is incorrect because EBS volumes do not have a native cross-region replication feature like S3 buckets do. The only way to replicate EBS data across regions is through snapshots. Quick takeaway, memory tip: snapshot, copy, restore. For EBS cross-region backups, always follow this pattern. Create snapshot in region A, copy snapshot to region B, restore volume in region B if needed. Remember, EBS snapshots equals official backup method. Lambda equals not for bulk storage transfer. S3 replication for objects, not EBS. EBS cross-region replication doesn't exist. Snapshots are incremental, encrypted, and fully integrated with AWS Backup for automated cross-region disaster recovery.